Hello and welcome back. Mrs. Saunders here. We're starting a new series of lessons on lines, all kinds of different lines. And today we're going to learn about parallel lines and transversals. New vocabulary, of course, and then learn about some angles that are created by lines and transversals. All right, so let's dive in. When two lines lie in the same plane and do not intersect, they're parallel. So here's a figure here, and we would say that in this figure, L is parallel to M. Or if we write it mathematically, it would say L is parallel to M. And look right here. That's the symbol for parallel, which is nice because it's these two little parallel lines. We mark parallel lines by those little arrows. If those arrows aren't there, don't assume the lines are parallel. So let's look at this box here, and let's look at the edge of the box. What other edge of the box would be parallel to that edge? This one. Let's take a purple line here. What edge is parallel to that edge? There's a bunch of them, but here's one of them. Okay, similarly, two planes do not intersect if they are parallel planes. So here's a drawing of two parallel planes. You can think about a room, and the bottom plane would be the floor and the top plane would be the ceiling. So you can probably look down and up where you are right now and see two parallel planes. Now this is different. Lines that do not intersect and are not coplanar, they're not on the same plane, are called skew lines. Another way to think about this is two lines that are going in a different direction but won't ever intersect. Okay, so let's take this edge of the box again. We need a skew line to my green line there. Well, it can't be this one. They're going in the same direction. They're parallel. So now we need a line that's going in a different direction, but it's never going to cross that green line. So again, there's a bunch of them, but there's one. There's one down there. See, it's on a different plane, but going in a different direction. So what would be a skew line to our purple line? Needs to be in a different plane, but going a different direction, like that. If you want to look at skew lines in real life, here's an example. We've got a bridge crossing over a pathway, going in different directions, but they'll never intersect. So if we look at it sort of in a two-dimensional form, let's just practice a little bit. Refer to the figure below to identify each of the following. All planes parallel to ABD. Well, here's plane ABD. See that? What plane is parallel to that? Well, if that's the top of the box, then the bottom of the box is going to be parallel to that, plane EFH. All segments parallel to CG. Well, here's CG, so we need any segment that's going in the same direction, like BF, AE, DH, those are all parallel segments. All segments skew to EH, right? There's EH. Now we need lines going in different directions that are never going to cross EH. So see if you can find a couple of those. BF, CG, those are kind of at the back of the box. What about on the top of the box? We've got BD kind of going crossways. BA, CD. Those are all skew to EH. All right, this next section of information is really important, and I need you to pay attention because, like a lot of things in math, this isn't something you can learn and then brain dump. This information is going to follow us and pop up throughout the rest of our geometry course. So tune in. All right, a line that intersects two or more coplanar lines at two different points is called a transversal. So see, we've got those two lines, those two blue lines, and if I take another line and cross those two blue lines, that's called a transversal. And when that transversal hits, all kinds of things are created. We've got all these different angles. I've labeled them 1, 2, 3, 4, 5, 6, 7, 8, all these different angles. And then we've got some different regions. Anything between the two original lines, that's called the interior. And what's outside the blue lines is called, shocker, the exterior. Now let's take a look at some of these angles. See all these guys, 3, 4, 5, and 6? Those are on the interior of that space there, so we call them interior angles. Well, what if we push them out? So 1, 2, 7, and 8, those are called, shocker, exterior angles. Okay, now we're going to get a little bit more complicated. Let's bring them in again, and we're going to look at some different kinds of pairs. So let's just look at 4 and 5 just a second. Just look at 4 and 5. Those are both on the inside, and in relation to the transversal, see, they're both on the same side of the transversal. So we call those same side interior angles. They're also referred to sometimes as consecutive interior angles. So you're going to see both throughout the course. Same side interior angles, consecutive interior angles. Those are the same thing. Okay, so 3 and 6, those are also same side interior angles. All right, let's do a switch. Let's switch 5 and 6. And now let's look at 4 and 6. Those are partners right now. And 6 hopped to the other side of the transversal. It's on the opposite side, but still on the interior space. So we would call that an alternate interior angle. 3 and 5 are also alternate interior angles. And if we push those to the outside, to the exterior, 1, 7, 2, and 8, those are alternate exterior angles. Okay, we're going to move things around again. Just look at 1 and 5 for a second. This is probably one of the trickier ones to recognize. So let me point something out to you. Here's angle 1, and notice it's on the upside of the blue line. And number 5 is also on the upside of the blue line. And then number 5 is on the left side of the transversal, and number 1 is on the left side of the transversal. So they're basically in the same spot. And when they're in that kind of relationship, we call those corresponding angles. So 1 and 5 are corresponding angles, 2 and 6 are corresponding angles. There's some more here. Let's look at this. 3, see, it's sort of on the bottom of the blue line, and 7 is on the bottom of the blue line. 7 is to the right of the transversal, and 3 is to the right of the transversal. They're kind of in the same spot. Those are also corresponding angles. So let's practice this a bit. First, we're going to practice just identifying the transversal. It's going to be a line that connects a pair of angles. So 4 and 10, what's a line that both of those angles share? Line G. What about 2 and 12? Those also share line G. 3 and 7, those are connected by line J. 13 and 10, those are connected by line K. All right, let's get a little bit more complicated. Now we're going to actually try to classify the relationship between different pairs of angles. So 10 and 16, first thing we need to do is find the transversal that connects them. Okay, so line Q, and then find the 2 other lines that complete the angles. Now look at 10 and 16 and think, okay, are they inside the blue lines or outside the blue lines? Well, they're outside, so they're exterior angles, and they're on opposite sides of the transversal, so they're alternate exterior angles. 4 and 12, we're going to find the transversal that connects them, the 2 lines that finish off the angles, and then figure out what their relationship is going to be. 4 is to the left of the blue line and below the transversal. 12 is also to the left of the blue line and below the transversal. So that means, what do we have? Corresponding angles. They're basically in the same spot. 12 and 13, there's the transversal, the lines that complete them. They're on the inside, they're on the interior, same side of the transversal. So those are same side interior angles. Okay, 3 and 9. First we find their transversal, the 2 lines that complete the angles. Those would be, what do you think? Alternate interior angles. 1 and 7. Transversal, lines that complete them. Alternate exterior. Couple more. 3 and 6, here's their transversal and the lines that complete them. Those would be same side interior angles. 12 and 14, let's speed up a bit. We've got a transversal, the two lines, alternate interior. And last one. 10 and 8, we need the transversal that connects them. And there is no transversal that connects them. So if that's the case, actually, none of these relationships even apply. So there's an introduction to, again, what's going to be a huge part of our geometry course. So if you need to go back and rewatch the video, do that. If you have any questions, let me know. Thanks for being here.